everyone, in this video we're going to be covering Peck scans with the TP20 touch trigger probe. I've already set up a basic reference system on this large test block, which is the plane, the large circle on the top and a line along the back edge. I've also done the best fit to CAD already. There's 4 exercises we're going to cover, so we're going to do a simple curve measurement on this radius and compare the profile to CAD. We'll then do a straight line curve measurement on this wave profile at the top. We'll then go into surface and measure this as an entire surface, and then as a final example we'll do a Peck curve scan that will be closed along this entire pocket and compare that to DXF. So let's dive in. So in the first example we're going to be measuring a curve profile along this face, this radius and this face, and checking this as a profile. So to do this, we start off, we're going to select a curve measurement. So this is for profile of a line, so it moves in a single line. And the first thing we need to do when measuring curves is make sure they're projected correctly. So we don't have any planes measured in the XZ plane or in the XZ view. So before we take any measurement points, we're going to define the plane and select the XZ machine plane, meaning it'll square up with this XZ machine plane. We now want to take 3 contact points. So the 3 contact points are the first point, which is the start, the second point, which is the direction, and then the third point, which is the end. So if I switch the camera on now, you'll be able to see this in action. So what I'm going to do is take a start point roughly here, and then what I like to try and do is take the direction and end points quite close together so that it doesn't go wandering off too much, as if the direction and end aren't aligned very well, it can go wandering off on the part. So I'll take the direction point here, drop down a little bit further, and then take the end point. So you'll see in the feature window there we have 3 points. All we need to do now is go to CNC, change from machine touch. So in the drop down box of the make moves window or section, if we click drop down box and then select Peck scan, and then after that all we need to define is the pitch. So the pitch is the steps in which it takes between contact points. So in this I'll try a 0.5 pitch, hit make, and then we can watch this cycle through by pressing play. So it goes to the start point, heads in the direction of the second point with steps of 0.5 millimeters. That's because I set the pitch to 0.5. And it gets feedback on every single point, which is why it's able to then work its way around freeform surfaces, like so. And it will keep pecking at that 0.5 millimeter pitch until it gets to the end. And that's it complete. So what we'll have now in the software, because I've already linked it to CAD, is the color coded heat map points of the contact points of the measurement. So we can see there, and we can also then dimension that entire curve as a profile of a line. So there we go. Now just to highlight the issues with adjusting the pitch, because you will have to mess around with the pitch depending on the size and variation of your surface. But if you do set the pitch too high, so just in this example, if I set the pitch to 5 millimeters and press make, if we watch that through, you'll see the steps become way too big and it ends up completely missing the surface. So we've completely missed the radius there, and we've only gathered 5 points, which is not what we want. So it's getting a happy medium between cycle time and data, and you do that by adjusting the pitch. The only other thing you may need to adjust is the pre-travel. This is the distance it backs off between points. So for more aggressive surfaces, i.e. more aggressive curves, you may need to adjust the pre-travel to avoid any crashes. So you might increase this to say 3 or 4, potentially 5 millimeters. But yes, that is the single curve measurement. Just to cover a final example with a single line curve, we're going to measure this freeform surface here And again, we're just following the exact same principles. So if I switch to the correct star now, we'll open up the curve. Now we do have a measured plane that we could project these data points into, or we can use the XY plane. Doesn't really matter. I'll choose measured in this example just to change it up and select this plane. So the data points will be projected into that plane. Again, it's a 2D single line curve. We are going to cover the surface in a bit. And now we just need to measure the 3 contact points, so the start, the direction and the end. So if I now go to the part, I'll take a contact point here to start, then I'll drive over, again trying to keep the second direction and third end points close together. So this will be the direction and then this will be the end. There we go, so we have the 3 contact points. Just move the probe away, and again we're going to go to CNC, change from machine touch to Peck scan, set the pitch. 1 might be okay here, so I'll try 1. We'll hit make and then press play. And there we go. So started at the first point, headed in the direction of the second point, and ended at the third point, with pecks in between of roughly 1 millimeter. So if we keep that open and just switch to software now, you'll see those data points have been overlaid on the CAD model. So we can see those as a color coded heat map. I'll just change the style here and adjust the tolerance. We can even adjust the magnification of the points. In relation to the CAD model, and as before we can dimension this curve as a profile that can show up in the tabulated report. So that is a slightly more advanced curve measurement on the wave profile of the large test block. So we're now going to look at measuring the same wave profile, only rather than doing a single line curve measurement, we are going to measure a surface, mapping out the entire surface of the wave profile rather than a single slice when we use the curve. So we now use surface measure, so open up a surface feature, and the key thing here, we don't need to define a plane like we did for the curve, as this is a Freeform 3D feature, and the 3 points that we typically would take with the curve measurement now define an L. So it's like an L, like the letter L. And these 3 corners, so top left hand corner, bottom left hand corner, bottom right hand corner, map out an oblong that the software will then measure as an entire surface. So let's just switch to the camera so you can see what I mean. So what I'll do here is I take a start point in the top left hand corner, a second point in the bottom left hand corner, and then a third point in the bottom right hand corner, like so. So it's not a straight line anymore, it's like the letter L. And then we go to CNC, and instead of just changing directly to touch points, Peck scan from torque points, with this example we go to use template positions instead, then change to Peck scan. I'll keep this at 1 millimeter. Press make, and then we'll watch this cycle through. I may need to speed this up. Let's go. there we go. So that is now complete. And again, if we look at this in the software, you'll see the points are overlaid to the CAD model, so we get the heat map. You can view the CAD videos if you want to see how to manipulate these data points, but yeah, we get that overlaid on the CAD, and then we can even dimension that as a profile of a surface because it's been measured as a surface, unlike the other features which were the profile of a line because they were measured from the curve feature. That's how we measure that as an entire surface. Just as a final note on surface measurement, let's say the feature you are trying to measure can't be defined by the standard oblong like the previous exercise. So in this example, say we're trying to measure this as a surface. It's obviously not oblong shaped. It also has the cone in the middle that we want to avoid. So all we do here is we take taught points, and when we make the feature, so when we hit the make button for the Peck scan, we leave it set to taught points, and all it'll do is scan between the taught points that we take. So take your touch points, make sure the path from point to point isn't going to crash into anything. You'll see here. Just taking multiple taught points, multiple touch points. There we go. So I've taken those touch points, and all I'll do is go to CNC, and instead of hitting use template, I'll keep it set to use taught points. Change it to Peck scan, set your pitch, I'll keep this to 1mm, press make, and then play. And there we go, so you see that complete. And again, if we just look at that in the software, you'll see we have the surface measurement with the heat map, and we can pull the profile call out just like normal. So that is surface measurement from taught points. So to finish off the video, we're going to measure a closed curve profile of this pocket, and we're going to compare it to DXF. So far we've been comparing to CAD, but just to mix it up and show the DXF functionality, we'll compare this curve profile to a DXF. So as with all curve profiles, we need to open a curve and then select the projection plane. So again, in this one we don't have a plane that we can project into, so we're going to use the machine planes. This will be the XZ because we'll be measuring in this view. So plane XZ, there we go, and then we're ready to dive in and start measuring. Now what we're going to do here is there's an option in the move parameters box, a little checkbox called closed. So click on CNC, you'll see it down here, closed. It's grayed out at the minute because we haven't defined the Peck scan points. So all we need to do is define the 3 points. So the key here is we just take 3. Now because we're going to use the closed option, we don't need to map out the start direction and end across the entire pocket. So we just take 3, so 1, move to the right slightly, 2 and 3, quite close together. And then if we keep it on taught points but switch to Peck scan, you'll see we have the option for closed here. I'll leave this at 1mm, I'll tick closed, and then I'm going to hit make. So if I just back that out now, what we're hoping to get when we press play is for it to start where we took our first point, head in the direction of the second one, but instead of stopping at the third end point, it will continue taking points around the profile until it gets back to the end. So there we go, that is the closed curve measurement complete. So now that we have the curve measured, we can import the DXF and compare the profile of the curve measurement points to the nominal data of the DXF. So all we need to do is go to the inspection toolbar, click on DXF, and then select import DXF file. Point it to the DXF file, open, and then we want to select import as curve profile, and then select your unit. So I know this one's in millimeters with a scale of 1. You can scale it via this box here. Select the plane that you want to import it into. So this is already picking XZ, but make sure this is selected correctly. And then put your tolerance in. So I know this is a 0.25 tolerance. So then we click finish. That brings it in the orientation that it was designed. But we can then manipulate this via the up-down arrows, which will move it up and down. It moves it up and down at the scale set here. So if I set the scale all the way to the right, you see the clicks take quite big steps. Take much smaller steps if we slide it all the way to the left. You can move it left and right here as well, and you can also rotate. So in this example, I'll slide this a little bit further to the right. And what you try to do is get it close enough by clicking the arrows, something like this will do, and then we press play. This will run the best fit. So if we press play, that's going to optimize to, and I've currently got it set to nominal, but you can use tolerance. And if the other features in the measurement program are also in the DXF, you can actually use features. It's outside the scope of this video, but yes, it's easy to get to grips with. Now that that optimization is done, if you zoom in, you'll see any points that are inside of that DXF window show up green. So in this case, everything's green. There's no issues there, so everything has passed. You can profile tolerance that just like we did with the CAD. So that is the DXF import.